Hello. Hi, we're going to talk about topics 5.1 and 5.2 today. We're combining multiplying integers and multiplying rational numbers together into one topic because the rules are exactly the same, and there isn't that much difference when multiplying decimals and fractions as there was when we were talking about adding and subtracting integers. We did talk about topics 5.1 and 5.2 last year, so this is review. We will do plenty of review, though, for this topic. So we're just going to jump right into the rules. And here we have talking about that if we have the same signs, your answer will always be positive. The product of two integers with same signs is positive. So they go on to show you that a positive times a positive equals a positive, or even a negative times a negative equals a positive. And we can also write 5 times, or positive times a positive, positive, negative times a negative equals a positive. Now, we do not want to use good guys, bad guys here. That only applies to adding integers. I'd like to talk about Mr. Scott and his matching socks here, though. If Mr. Scott is wearing both blue socks, then he is a happy guy. If he's wearing both brown socks, he's also a happy guy. There are times when he does not wear the same color socks, and when that happens, then he gets into a bad mood, which is negative. The product of two integers with different signs is negative. So positive times a negative will give you a negative, and a negative times a positive gives you a negative. And then they also give you some examples with more integers here. And then I remind you that the sign rules for multiplying integers work for all rational numbers as well. Our first set of examples here, just kind of trying to cover this up here. I haven't quite mastered this just yet. For our first set of examples, they want us to organize these two things into two groups. I'll move this up. Just give me 1 second. They want us to organize all of these. And of course, there's the answer. I will get this eventually. Okay. What I'd like you guys to notice is that each of these terms, this one is 3 times negative 4. We have two terms, 3, 3, 2, 3, 3, 2, and 2. In this set, there is one negative. This expression, there is 2. This one, there's 1. This one, there is 2, 2, 3, 1, and 2. And out of the numbers 1, 2, and 3, 1 and 3 are odd numbers, and 2 is an even number. And where that is important is that we will know the sign of an expression regardless of calculating it out. If it all has multiplication and division, you will always know what the sign of your expression is going to be based on the number of negative signs. If there is an odd amount of negative signs, then your answer will be negative. And if there's an even amount of negative signs, then your answer will be positive. So that's what I covered up right here. If you guys could go ahead and write that down, that an even amount of negative signs, then your answer was positive, and an odd amount of negative signs, your answer is negative. Pause the video if you need a second to write that down. So now if you look at all of these products here, or all these expressions, they all end up equaling 12 or equal negative 12. So that's why they have either equivalent to 12 or negative 12. So really, you could go through this pretty quickly and say that there's 1 here, that's an odd number, so this answer is going to be negative. There's 2 here, so that's an even number, so the answer is going to be positive. So if you could go through and fill in where these go into either equivalent to 12 or negative 12, pause the video, and when you come back, it'll be all ready. So here I have my answers of 4 times negative 4 times negative 3, an even amount, 2 negative signs, 2 negative signs, 2 negative signs. So all of those are equivalent to 12. Over here, I have 1 negative sign, 1 negative sign, 1, 3, and 1. So all those are equivalent to negative 12. Then number 2 is now asking which products are equivalent to 36. So if you guys could go ahead, again, take a look at that one, pause the video. And I said 1 and 2 here are both equivalent to 36 because there are an even amount of negative signs in 1 and 2. And number 3 has an odd amount. So I know that that one's going to be negative. I also just went through and calculated them for fun to show that I do get positive, positive, and a negative. Now, question 3 is asking us to dive a little deeper here. They're saying, suppose that P and Q are non-zero integers with different signs. Is the product P times negative Q positive or negative? Sorry for that. And all I'm going to do here, I'm going to redo my example on this piece of paper here just because I have already got it done. Because this is my second take at the video and I only brought home one blank copy of the notes. So what we're going to do here is they're saying, suppose P and Q are non-zero integers with different signs. Is the product P times negative Q positive or negative? Now, when you look at this, they're saying this one is positive and this one is negative Q. So some people might think already that, oh, they've already taken care of the two different signs for me. Be careful, that's just the expression that they happen to be giving us. So we still need to assign P as a positive and Q as a negative, or vice versa. P is a negative, Q is a positive. So P I'm going to just make 1, Q I'm going to make negative 2, making these easy numbers for myself. So when I substitute these into P times negative Q, I'm going to put 1 in place of the P, and then I have to bring the negative sign from this Q right here, and then the negative 2 over, and calculate this. Now this is not 1 minus negative 2. I'm showing multiplication here between the parentheses. This becomes 1 times negative and a negative together. Two negative signs together make a positive. So this becomes 1 times 2. So my answer actually ends up being 2, which is positive. And that's my explanation. Sorry about that. I also could show you if I flip-flopped it, if I had P equals negative 1 and Q equals 2, I would still get a positive because when P equals P times negative Q, P is going to be negative 1, and then Q, I have to again bring this negative sign down, so this becomes negative 2. Negative times a negative, again, gives me a positive. All right, so we're going to turn the paper over. And on the back, they're asking us again to sort these tiles into 2 groups. And there we go, I'll go this way. If we look at all of these tiles, they all have a 3 and a 1 and 5/10 in there, and then some are positive, some are negative. So again, 3 times 1 and 5/10, well, 3 times 15 is 45. Move the decimal over 1 place, will give me 4 and 5/10. Some of them will give me a negative, and some of them will give me a positive. So I'm going to group these into positive 4 and 5/10 and negative 4 and 5/10. So this is basically the same thing that you did on the front. So go ahead and separate those two into groups. And pause the video. Now, they chose to use a dot to show their multiplication, which I thought was kind of cruel here since they also give you decimals to deal with. So be careful that you can tell the difference between your decimal and your multiplication sign. Some of these I wrote down kind of quickly, so even I'm having a difficult time seeing. But just see that to get positive 4 and 5/10, I have obviously a positive times positive stays positive. But here I have an even amount of negative signs, so my answer ends up being positive. Here I have an odd amount, so all of those end up being negative. Now, number 5, we're going to be adding a couple caveats here, a couple things that we need to pay attention to. They're asking you, if A is negative and B is positive, is A squared B positive or negative? And instead of assigning numbers here, I'm actually going to solve this algebraically. So again, just bear with me. Over on the side here, I've written that if I was to take negative A, this is a negative sign, and square it. Notice I'm putting parentheses around the negative a because I'm trying to keep that negative sign safe. If I take negative a and square it, that is equivalent to negative a times negative a in extended form. If I take a squared, positive a squared, then extended form, that is a times a. So I'd like you to notice that this would end up giving you a positive a squared, and this one would also give you a positive a squared. So even if a starts out being negative, you still end up positive at the end. So I've rewritten this expression that they've given me, a squared b, and I've now made a negative. So it's negative a squared, and b is positive. So negative a squared, again, over here on the side, I've now said is negative a times negative a, which is really the same thing as a squared. And I still bring down the b. And then so I have a squared times b gives me a squared b, which would tell me that my answer would be positive. Now for the next couple questions, I'd like you to write this down. I'll put it in a nice little box here. That this negative sign, where you place it when we're talking about fractions, always tends to confuse people. Just know that if you were to take 2 divided by 3, you would get 6/10 repeating. So if I was to take negative 2 divided by positive 3, I would still get negative 6/10 repeating. If I was to take 2 divided by negative 3, I would also get negative 6/10 repeating. And then if I had 2 divided by 3 and then put the negative sign on at the end, I'd also get negative 6/10 repeating. So I really don't have a preference where you have your final negative sign hanging out. They all equal the same thing. So I think that you can go ahead and try number 6, all 3 of those examples there. Just make sure that you're mindful of the negative signs and pause the video. When you come back, these will be all done. Sorry, my son's crying. Hopefully my husband will go get him. So I've got 8/9 times negative 3/4. We saw that we could cross cancel with both of those. Be careful that when you cross cancel with the 9 and the negative 3, that you have, I actually rewrote this as -1. You don't want to lose that negative sign, because if you lose the negative sign there, your answer will be incorrect at the end. So I cross canceled both the 8 and the 4 as well, and I ended up with negative 2/3. For the second one, I had to change -1 3/7 from a mixed number to an improper fraction. When I multiply, that's what I need to do. So remember again to keep your negatives. I like to have my negatives hang out in the numerator. Again, you're welcome to have them hang out in the front, just like this one over here. You cannot cross cancel anything here. So we end up with a negative times a negative, which gives us a positive. And 10 times 2 is 20. 7 times 1 is 7. And as a mixed number will give me 2 6/7. For the last one, boof, there's the answer already. I'm going to take -2 1/8, change it to a mixed number. Then I am going to multiply straight across. I have a positive times a negative, and so my answer will be negative 51/64. The last one is a word problem for you to take a look at. Again, pause the video, and when you come back, it'll be all ready. Okay. So in this one, if the investor owns 203 7/200 shares of Glacier Futures stocks, the value of the share of stock drops 15 cents. Find the total change in the value of the investor's stock. You have to multiply those two together. And so the negative sign, again, is telling us the direction that did the stock go up or did the stock go down? And it being a negative, it dropped $30.56. Thanks for watching. We'll see you tomorrow. If I can figure out how to stop it.